probability. Today, we are just putting numbers to that intuition. So there is only one rule today. The answer must be between 0 and 1, or you can say 0% and 100%. Okay. Think of your phone battery percentage, like 0 means 0%, it's dead, and 1 means 100%. So every event in the universe falls somewhere under this glowing line. Okay. So if you want to say 10%, you can say 10%, or you can say 0.1. Your choice. You can say 45% or 0.45. Your answer must be between 0% and 100%, or 0 to 1. Okay. So here is a quick test. So say if I flip a coin, what is the chances that it lands on heads? You can type in comments, or you can say out loud whatever you feel like. Someone saying half. Okay. Any other guesses? Anyone else wants to try? Okay. So he is absolutely right. It's 50-50, or 50%, or 0.5, or as he says, half, right in the middle. So here is another question. In the left side, say uh, I roll a die, 6-sided die. What is the probability of rolling 7? Can anyone answer? 0, 0. Yeah. So you guys are right. The probability is 0. It's impossible to roll 7 on a 6-sided die. And in the right side, what is the probability that sun will rise in the east tomorrow? Anyone? 100%. Anyone else wants to try? Okay, so we'll go with that 100%. This is an obvious event or a certain event, so it will be 100%. So you guys are comfortable with the 0-1 scale, and you are good with your intuitions, as I see. So let me try to break it now. So I will, you can read it in English. I will say simply in Bengali this one. Okay. So তোমরা মনে করো যে একটা রুমে 23 পিপল আছে, ঠিক আছে? যেমন আমাদের এই মিটিং এ কজন আছে? 21 আছে। তো আমি এখানে একটা কোশ্চেন অ্যাজ 23 সেট করেছি ইন জেনারেল। তো 21 দিয়েও ভাবতে পারো, 23 দিয়েও ভাবতে পারো। তো তোমাদের এখানে কোনো দুজনের বার্থডে বা 2026-এ তোমরা সেম ডেটে কেক কাটবে, আমি ইয়ারটা বাদ দিলাম, তোমরা দুজন সেম ডেটে কেক কাটবে, তার প্রবাবিলিটি কত? কি মনে হয় তোমাদের? তোমরা চ্যাটে জানাও, আমি একটু দেখি কেউ কারোর অ্যান্সারে ইনফ্লুয়েন্স হয় না, নিজেরা জানাও। আজকে দেখি তোমাদের কেউ বার্থডে টুইন অ্যাজ ইওর জেনজি ল্যাঙ্গুয়েজ আমরা খুঁজে পাই নাকি। তো হোয়াট ইজ দ্য প্রবাবিলিটি? এখানে আমরা যে 21 জন আছি, এখানে দুজনের বার্থডে সেম ডেটে হবে। 365 ডেজ থাকে একটা ইয়ারে, তো দুজনের বার্থডে সেম হবে। ইউ ক্যান গেস এনিথিং, নো ম্যাটার। সো আই ওয়ান্ট সাম গেজেস প্লিজ। Anyone wants to try? Please, you can guess.
Should we guess the year?
No. The number of people, like there are 23 people. How many people here will have same birthday? Like, ma'am,
3
what's
to
your
4.
birthday?
My birthday is on 13th April.
13th April. So, do you think the 21 people here will have same birthday of yours?
No, the probability might be 2 to 3 people.
Like 2 to 3 people can have same birthday of your here, like in 21
No,
people.
not here. There might be 0.
I'm talking about here. Like here we have 21 people, 22 people to be precise. So how many people here will share same birthday? Like one
I think
pair,
no
two
one.
pair.
I
You
think
think
no
no
one.
one? Any other guesses from anyone? Anyone thinks anything else? Okay, no one wants to talk. No problem. So ma'am thinks it's no one, or I can say that it's very less, ma'am is saying. Or like, let me try to break that. So to understand that, we first understand what is Paradox. First, look at this classical loop. This is Pinocchio. For those who don't know the story, he has a simple curse. His nose will grow if and only if he tells a lie. So what happens if he says, "My nose will grow right now"? Think about it. If he is telling the truth, his nose shouldn't grow, which makes his statement a lie. But if he is lying, the curse says his nose must grow, which makes the statement true. We have visual paradoxes like this pen or step where you go nowhere. See, if you are standing here and you climb upwards, you are still climbing upwards, still climbing upwards, still climbing upwards, but you end up in the same spot, but you never go downwards. And if you start climbing downwards, see, you are ending up in the same spot. This look impossible, no? Your brain can't process this. So we also have language paradoxes, but these are fun, but there are flaws in perception or language. But the birthday problem, that is different. The birthday problem is a veridical paradox. It feels false, it feels impossible. But unlike word games, the math proves it is 100% true. Remember, ma'am grades, it's very low, and some of you who are listening, they also might think no one here will match my birthday, no? But the probability is 50.7% with just 23 people. Like two people here matching the same birthday, is chance is very high. If you are non-science students, you may call it magic, but if you are a math student, you know it's just logic. So we have collected birthdays for this season, if you guys remember. So there was a reason behind this. I told them to collect your birthdays. So this is not just a presentation and I tell you that is 50.7% and you guys believe, oh, sir says so it is. So no, I will now, one second, let me present that screen. So here is your data. This is your actual data which you guys filled. I just hide those personal informations. So here, as I can see, I can call them Mr. Rajarsi Mahato. Are you here? Is he here? Can anyone check from that side?
Yes, sir.
Okay. And Tushar Das, are you here? So you two guys, see, 12 and month is 8. You both have same day in 2026. Same day you will cut cakes. Okay. Uh, uh, the month is 8 and the date is 12. Also, we here have Taroknath Mohato, uh, whose birthday is 22nd of March, and he is matching with Miss Semonti Roy, whose is 22nd of March. And also we have a very perfect match. Is she here? Benita Roy, are you in the meeting? Present? Are you present? Miss Benita Roy. Yeah, I'm seeing her name. Okay. So her birthday is 11th January 2006. And we have Mr. Somodip Das. Somodip Das, are you here? Somodip Das. Yeah,
Yes, yes, I'm,
yeah.
yes, I'm here.
So your birthday is 11th January 2006, and you are matching with Binita Roy, whose birthday is exactly 11th January and 2006. And this is, see, this is data number 26. So I told 23. So in 24 we also have matches. In 14 we have matches. In 26 we have exact matches. And also we have another like here Soumojit Haldar, if he is present, and Rajiv Mahato if he is present, and we also have no more. So we have like 5 matches here. Okay, so this is the actual data you filled. I am not created. I have not created this. No, This is the actual data you guys created. So you can see the match is very likely in just 23 people, which seems impossible. Like, how can this happen? Like, there are 365 days in a year and we are only 23 people. And see, now the people count is 23 here. So 23 people, and we are matching birthdays, and not just one, not just two, there are five birthdays are matching. How is this possible? So let me dive into that. Okay. So for anyone interested in the calculation, here he can refer this. I am not going deep into this, you can ask me later. We don't calculate the chance of a match, we calculate the chance that everyone is unique and subtract it from 1, as we do in probability. As n climbs here to 23, we put it 23 here, and the probability of unique set collapses, and the chance of collision flips over 50%. And also there is a website, let me tell you that there is a website. This is Wolf from Alpha, and if you search birthday problem calculator, you don't have to do the math, you can calculate it yourself, just putting n here. Here I put 23. Okay, so now let's jump into our presentation. Okay, so why does this happen? Because our intuition is selfish. We think, what are the odds that someone matches me? That chance is tiny. But the math is checking if any person matches any other person. With 23 people, we aren't just making 23 comparisons. We are making 253 pairs. That is 253 lottery tickets. You are bound to win something. Okay, so how this 253 pairs comes, if you might ask, then we have a concept called combination. If you do 23 combination of two people, you get 23 into 22 divided by 2, which comes to 253. Okay, if you are interested, you can ask me later, I will do the calculations for you. Okay, so if 23 people just gets us to 50%, if I want to be 99.9% certain, basically guaranteed to have a match, how many people do I need, you think? This is 365 people, 1000 people, how many people do I need? The answer is 70. With 70 people, we are checking 2415 pairs. It is mathematically impossible to avoid a collision. And this is the concept. The inevitable collision is what hackers use to break the internet. So in a room, we call it a shared birthday, but in computer science, we call it a collision. To a mathematician, a collision is a curiosity. To a hacker, a collision is a key. This is the birthday attack. To understand how, we first need to understand what a digital birthday actually is. We call it a hash. To understand hash and how we protect the internet, we need to look at the one-way function. Think of it like multiplication, but slightly harder. If I give you 24 and 30, you can multiply them instantly to get 720. This is in forward direction. It's fast, it's easy. But what if I hide the inputs, give you just the number 720 and ask, which two numbers did I use? Now it gets difficult. Was it 24 times 30? Was it 72 times 10? Was it 9 times 80? You can't be sure. You have lost the original secret. This is how we turn a password into a digital fingerprint. So in real world, we don't use number like 720. We use hash. Look at the screen in the top box. I typed hello, and I generated this using MD5 hash generator. And MD5 means, like, 5 refers to the power 5, which is 32, a 32-bit encryption system. The computer turns it into that long string of this green character. But in the bottom box, I just added an exclamation after the hello. Look at the result now. It didn't just change a little bit, but it changed completely. This is called the avalanche effect. A tiny change in the password creates a massive chaotic change in the fingerprint. This makes everything reversing very difficult. Okay, but very difficult is not the same as impossible. And here is the flaw. In our first example, your password was 24 times 30, which equals to 720. But a hacker doesn't need your password. They just need another pair of number that equals to 720. If they guess 8 times 90, that also equals to 720. To the computer, your secret password and the hacker's guess looks identical. This is a collision. So how do we stop the hacker from finding that collision? We have to increase the size of the room. So remember, in the past eras, we used 32-bit system, 32-bit computer, and now we use 64-bit. So 32-bit is like a small jar. There are only like 4 billion possible birthdays, which we are referring previously, birthdays. So 4 billion possibilities. A modern gaming laptop can find a collision here in seconds. It's unsafe. So 64-bit is better, but supercomputers can still crack it using birthday attack. 128 bits, this is galaxy. The number of possibilities is huge. And there is also 256 encryption, which is currently the highest. It is called SHA 256. This is like a universe. The number of possibilities in 256-bit encryption is larger than the number of atoms in the known galaxy. So we use big room to separate the data. But remember the paradox. No matter how big the room is, if you put enough people in it, two will share a birthday. In the digital world, we don't call them people, we call them files. And when two different files produce the exact same hash, that is the same birthday, we call it a collision. To a human, the files look different, but to the computer checking the hash, they're identical twins. And this is exactly what the hackers are hunting for. Now, here is the birthday attack. Mm, Here is how the birthday attack actually works. Imagine a hacker wants to trick you signing a fake contract. They write a legit contract like buying a coffee, and they also write a fake contract that is selling your house. They use the birthday paradox. They don't need to break the encryption password. They are just using a supercomputer to make millions of tiny changes into the fake contract, like adding a space, having a comma, changing the font size slightly. They generate millions of versions of that fake contract until bingo, they find one specific version of the fake contract that matches exact same as the legit contract. The fake contract that creates the exact same hash will now replace the legit contract. Remember our graph with 70 people connected by lines? The hackers just generating enough people, that is files, until the math or the birthday paradox guarantees a connection or collision. Once they have the collision, the game is over. You review the legit contract, you sign it, your computer calculates the hash and gets a XYZ. In split second, the hacker swaps the fake contract, the bank system to the bank system. The fake contract also calculates the hash. It's also XYZ. The computer says verified, the transfer goes through, but you just signed your house instead of buying a coffee. This is the danger. The computer checked the hash like the birthday, not the person like the original contract. And because of the paradox, the hacker fooled the system. Let's forget this all complex things for a second and let me tell you this in a very simple example. Think of a hash like a digital wealth. The computer system is like a courier. It doesn't open your parcel to check if it's real, it just waits it. In real time, say you order an iPhone, the computer waits the digital file, like the iPhone, it says 150 gram. A hacker wants to send you a soap box. Obviously, a soap bar weights differently, but the hacker uses the Pareto paradox. It takes the soap and makes millions of tiny invisible changes, like adding a byte here, deleting a space there, and keeps modifying the soap until he creates a version that weighs exactly 150.00 grams. Now, the blind courier, I mean the computer, the iPhone and the soap bar are identical because it's just checking the weight. So here is how the attack will go. The delivery system runs a security check and it puts the iPhone on the scale. It reads 150.00 gram. It says authorized. In that split second, the hacker swaps it with the soap bar and the server weights it same 150.00. Because of the collision we just created, it will also weight 150.00 gram. The server says weight matches, deliver it. You open the box expecting an iPhone and you find a soap bar. The system failed not because it was broken but because it was blind. It trusted the weight, I mean the hash, instead of checking the content. So is the internet broken? Is your bank account unsafe? No, because we found a solution. We stopped using simple scales like that MD5 I first show you generated a hash that round things off. Today we use SH256. This system measures digital weight of a file down to atomic level. In the old system, faking weight was easy, like 150 gram was easy. But in the new system, the computer demands a weight of like 150.0000002938 grams. To fake that specific weight with a soap bar is mathematically almost impossible. We beat the hacker not by changing the laws of probability, but by making the measurement so precise that no two files will ever collide. So we started this session with a simple question. What are the odds of a shared birthday? It felt like a party trick, a simple puzzle. But as we peeled back the layers, we saw that this simple probability rule is the engine behind modern cyber warfare. The same logic that predicts a birthday match is the logic that hackers use to attack and the logic engineers use to defend. This is the beauty of applied mathematics. It is not just lines on a chalkboard, it is the code of our reality. This is the invisible shield that protects every message you send and every rupee you spend. Thank you for your attention. That's been my time. Anyone have any questions to ask? Anyone wants any questions to ask?
No, sir.
No. Anyone else? can everyone here present just hands up or some do something so I can
Okay.
conclude. Yeah.
Hello.
Yeah.
Does anybody else have any question to ask? Does anybody else has any question to ask? Okay. Since it is evident that nobody else has any question to ask, so sir, would you like to conclude the session now?
Yes, ma'am.
Okay. Thank you so much for your insightful talk. Since there is no more question to ask for the ask from the participants, now I would like to conclude the session. And before that, I would like to tell everybody that the link of the feedback has been shared in this meeting and will be shared in the WhatsApp group. And those who have attended the meeting as well as provided the feedback justifiably will get the certificates. Otherwise, anybody else won't get the certificate. Now, I would like to conclude the session thanking everybody. Especially, especially I am really grateful to Mr. Prosenjit Naik and Mr. Intranil Basu for supporting this program in all possible way. And next, I am grateful to the student coordinators, that is Shreya Chakraborty, Rajoshi Mahato, Bornona Kumar Maji, Chetona Banerjee, for coordinating this session so very much efficiently. I am really grateful to the participants for your heartfelt participation. And last but not the least, I am really obliged to our honorable speaker for your valuable time. Thank you so much, sir.
Thanks a lot, ma'am. Thanks a lot. So can I leave the meeting now?
Yes.
Okay, ma'am. Thank you. Thank you, everybody.